Okay, we are going to wrap up our solving with a very important technique. They use this a lot in calculus, and it's called an A substitution. So when you start to solve something and it looks really complicated, you take out the complicated thing and you call it an A. You continue solving with a nice A, and then you put that complicated thing back in. So first of all, let's look at this equation. We're solving for x. Cannot add these like terms, but I could make some common bases if I change everything to a 2. So let's say that this is 2 to the power of 2x minus 2 to the x minus 12 equals 0. Now we can't add these because their exponents are different. What I am going to do is rearrange this a little bit, and I'm going to call this 2 to the x, so it matches that one, but he has to be to the power of 2. Is that correct? A power to a power is powerful. We would multiply. Yeah, that definitely works. Minus 2 to the x minus 12 equals 0. So now I like the fact that I have 2 to the x in both places, except here it's quantity squared, and here it's all by itself. So this is what I was talking about, how it looks really complicated, and so we're going to use an A to come on in and help us out. You have to officially say, let A equal something. If you're going to change the equation, you have to tell people what you're doing. I'm going to make A be the complicated thing, the 2 to the x. So let's rewrite our equation now with a's. If this 2 to the x is called a, this would be a squared. And then I've got another 2 to the x, which is just minus a minus 12 equals 0. Well, this looks like something I could certainly solve. In fact, it looks like something I can factor. Make sure you write a's. A and a. How we're going to get a negative 12 is if we have one of them be negative, one of them be positive, the 4 needs to be negative, the 3 is positive, and so my answers are A equals 4 and A equals negative 3. Wait a minute, this equation didn't have A's. Okay, thank you, A, for making the problem so nice and easy, but it's time for you to go now. So what was this A thing? Oh, that's right. A was 2 to the x. So let's replace A with 2 to the x. So the A is really just holding the place for the complicated thing so it looks easier on the eyes so you could solve with your usual techniques. Now, I'm noticing that x is still not solved for. He's in the exponent. How do you get somebody out of an exponent? Well, we switch to log form. Actually, this one we could just make common bases. Maybe some of you even know x just equals a 2. All right, that was easy. How about this one over here? This one, we're going to have to do a log equation. The base is 2. We put the x over here. The of is negative. Wait a minute. Can you take the log of a negative? This one is no good. There's only one answer to that equation. This one's called extraneous. Okay, let's try it again. Here's another time where it would be a great place to use an A substitution. First, maybe I'll do some algebra on this. First, we're going to do some basic math and get it ready. We'll multiply both sides by 2. So e to the x minus e to the negative x equals 10. That is not ready yet. Let's see. When you have a negative exponent, maybe I'll move him into the basement. E to the x minus 1 over, bring the e downstairs, his power's positive, minus 10 equals to 0. I couldn't add them because the powers were not the same there. Now they're in the different places. Can you tell what the complicated thing is? The first step to being able to do this is recognizing what you're going to make the A thing be. Let's officially write down. A is going to be what? E to the power of x. So let's take our equation and let's write it with A's. This first term right here, that's just going to be an A. Minus the second term here is 1 over A. Minus 10 equals 0. Now, I don't like having that a in the denominator. We're going to have to multiply the entire equation by an a. The first term is going to become a squared. What's 1 divided by a times by a? Well, that cancels out and makes just a 1. Minus 10a right there equals to 0. Let's put this in descending order. Okay, and now let's try to factor. Oh, it doesn't factor. Okay, when something doesn't factor, then we're going to go ahead and use the quadratic formula. The quadratic formula starts off with the variable that you're trying to solve for. The variable that we're trying to solve for here is a. So you must start off by writing a equals. Very important. Very important. Start off with a equals. This equation has a's. Negative b plus or minus the square root of b squared minus 4ac. That becomes a plus all over 2a. Let's see. A equals 10 plus and minus the square root of 104. All of that over 2. Let's see if we can simplify 104. I know I could take out a 2, and that gives me 52. 52 can be divided by 2, so let's go ahead and say 2 times 2, and half of 52 is 26, so a 2 can come out of that radical. So a is 10 plus or minus 2 comes out, radical 26 stays home, and at this point I'm going to give them each their own denominator of 2. If I don't, people tend to cancel the first one and not the second one. We're going to get this right because we're going to do each of them. And a is 5 plus or minus radical 26. Great. Wait a minute. This equation didn't have a's. Now that you've solved for a's, it's time to bring your e to the x back into play. So a, thank you for helping, but you got to get out of here. E to the power of x is 5 plus or minus radical 26. Now, how do you get an x out of an exponent? We're going to have to switch to log. What kind of log are we going to use when the base is an e? That's right, a natural log. Natural log of all this stuff. We're going to have to make sure we use parentheses here. 5 plus and minus radical 26 equals x. Let's check with the log circle to make sure we did that correctly. E to the power of x equals that stuff. Now, I have to ask you guys, are both of these going to be okay? I know 5 plus more. That's okay. You cannot take the log of a negative. What about 5 minus radical 26? Well, I know radical 25 would make a 5, so this is more than 5. This is like 5 point something. What's 5 minus 5 point something? That's going to be negative. So our official answer here can only be the positive one. 5 plus radical 26. Sometimes they're both good. Sometimes one of them's good. Sometimes neither of them are good. So you have to think about if it's going to be positive or negative. Okay. Let's do some more A substitutions so we get really good at this. The next example I have here has a bunch of 3's with exponents of x and negative x. Let's do some baby algebra and multiply both sides by 2 to start with. So 3 to the x minus 3 to the negative x equals negative 4. Maybe I'll clean this up a little bit by saying 3 to the x minus, I'll move him downstairs, 1 over 3 to the x. I'll add the 4, make a 0. Okay, can you tell what we're going to have the A thing be? We're going to let the complicated thing that you see here is 3 to the x. That's going to be your A. So let's go ahead and write that out. The first term is just an A. Then you have 1 minus 1 over A plus 4 equals to 0. This is very similar to our last equation. Can't solve it like this, so we're going to have to multiply the entire thing by an A to to eliminate the denominator. So when you multiply over here, the first term becomes a squared minus. This is some place that people mess up. They say a, but it's not. The a's totally cancel, and you just get a 1. Here is where you're going to get plus 4a. So when you're doing these, make sure that one of your things is squared, one of them is the linear a, and one of them is the constant. Then you can rewrite this in descending order, but that's how they're always going to look. Okay, can this one get factored? No? All right, then we're going to have to use quadratic formula. And how is it going to start? You're going to start, it's not x equals, okay, x is going to have to come back later. This is a equals negative b plus or minus the square root of b squared minus 4ac. That's going to become a plus all over 2a. Okay, let's go over here. A is going to be negative 4 plus or minus radical 20. Yep, 2 radical 5. And we'll divide each of them by a 2. Okay, so the final answer for A, negative 2 plus or minus radical 5. Oh, but wait, that was the A thing. So thank you for helping, but it's time for you to come back out. The A thing, what A represented was 3 to the power of x. So we're going to say that, and then we have to get x out of that power. We're going to have to change to a log. And the base is going to be 3. Log base 3 of negative 2 plus or minus radical 5 equals x. Did I set up that log circle the correct way? Yes. Now, are both of those answers going to work? Hang on. A negative minus some more, that one's definitely not going to work. Now, what about the positive one? Radical 5 is more than radical 4. Radical 4 would make a 2, so radical 5 must make 2 point something. Negative 2 plus 2 point something. Oh, that's going to work out okay. That's going to be positive. So the only answer this time is going to be parentheses. Negative 2 plus radical 5. You must put all of that of in parentheses. Without the parentheses, it looks like it's after, and that is technically wrong. Okay, sometimes both of the answers get crossed off, sometimes only one, sometimes none. All right, we got one more here. And this one I'm going to have to do a little change of base on. I'm going to have to make an A thing be the same. So I'm going to make 9 be 3 squared. Power to power is powerful, so that's 2x. Minus 3 to the x plus 1. Okay, I still don't see anything that's the same. I have to find something that the A can represent. Here I'm going to make 3x be raised to the power of 2. Okay, that's good. Now everybody watch very closely what I do here. I'm going to take 3 to the x plus 1 power, and I'm going to write it as 3 to the x times 3 to the 1. Wait a minute. Is that right? If I have bases that are the same, would I add or multiply those powers? I'd add them. So does that work out the correct way? Yeah, once you do this a couple times, you'll realize that you're going to split them up and give them each their own base. Plus 1 equals 0. Now, can you tell me what A is going to represent? Let A equal 3 to the power of x. Okay, let's rewrite our equation, but with a's. So this is going to be a squared minus this one right here. This right here is going to become an a times 3 plus 1. That looks a little silly, so I think I'm going to write it as minus 3a. Okay, so take a look at that right there and see first, do you understand how I split it? Next, the a thing was right there, and then there was a 3 after it, but I like to put the coefficient in front. Can this one be factored? Nope, I don't think so. So let's solve. A equals negative b plus and minus the square root of 9 minus 4ac all over 2. So A is 3 plus or minus radical 5 all over 2. Nothing can cancel, so you can leave it like that, or you could separate it into separate fractions if you like. But I think it's time for 3 to the x to come back. So 3 to the x, where'd you go? 3 to the x equals 3 plus and minus radical 5 all over 2. How do you get something out of an exponent? We're going to have to switch to log. And what's the base? 3. All this stuff is going to go into the of equals x. Let's just do a quick log circle. Make sure I set that up the right way. Okay, you need to use parentheses there. Now, in terms of having a domain that works, the positive one is going to be good for sure. 3 minus. Well, I know radical 4 is 2, and this is more. So this is 2 point something. What's 3 minus 2 point something? Oh, that's going to be positive. So they're both good this time. Sometimes they're both good. Radical 9 would make a 3, and that would not be good. But radical 5 is less than radical 9. Okay, what do we got next? Oh, just a regular solving? Solving with logs? Okay, let's see. Can I just say that these ofs are equal? No, I cannot do that because there's a 1 there. So that rule is when a log equals to a log, and that's all you have. Unfortunately, I have a 1, so I'm going to have to get these logs together. I think I'm going to put this log on the other side. At least all the logs will be on the same side. So let's move this log over. We'll add it, say plus log base 5 of x minus 1. And I'll leave 1 on the other side. Okay, I wish there was a way to make all these logs turn into 1 log. There is a way, you say? All right, so we're going to make the logs come together. The base is going to be 5. Do those bases have to match? Yes. When you're adding them, what do you do to the ofs? That's right, you multiply. So let's go ahead and multiply. X squared, outers and inners make plus 2x minus 3 equals to 1. Now, you're not going to say this stuff equals 1. This is not a log and a log. There's only 1 log. When there's only 1 log, how do we do this? That's right. This is a log circle problem. So we'll start with 5 to the power of 1 equals x squared plus 2x minus 3. Let's get everybody over on one side. We'll subtract 5 and get minus 8. And does this one factor? Oh, I believe this one factors. Oh, thank heavens. 8 can be calculated by doing plus 4 minus 2. So there's 2 answers, negative 4 and positive 2. Are they both going to be okay? Let's go back to the original problem right here. 2 will be okay in each of those ofs. You don't want to make a negative of. Is negative 4 going to work? No, he's going to make a negative in both of them. So negative 4 gets crossed off. The only one you'd put on the answer line is 2. Okay, I've got one problem for you to try here. The video is going to end, but your notes need to keep going. I need you to try this one right here. First, can you tell what the A thing is going to be? And then, can you substitute it in? Good luck. I can't wait to see your answer.